this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 5-1 in the SavvasRealize Algebra 2 textbook. In today's video, we are looking at evaluating expressions with rational exponents. Remember, when we're talking about rational, we're talking about fractions. Alright, so example 3 here just tells us to evaluate the expressions. Alright, so we're looking at how to simplify these radicals. I'm going to try to show it to you a little bit different than the book does. I think that it's a little easier to understand in different ways. So first, I like to write these as what we call the radical form. Alright, this is called the exponential form because it's written as an exponent. The radical form, you guessed it, is written as a radical. Now, in general, kind of my default way is I usually put the exponent, so the numerator of the fraction, here on the outside. Sometimes when I look at it and it doesn't really simplify cleanly, then I'll move it on the inside. But to start out, I usually put it like this. Alrighty, now 32. I'm going to use a factor tree to help me to break down 32 because I may not know how to evaluate that off the top of my head. I know 32 is 8 times 4. And 8, I know, is 2 times 2 times 2. And I know that 4 is 2 times 2. So really what I'm evaluating is the fifth root of 2 times 2 times 2 times 2 times 2. Then I'm cubing it. Now this index, I like to think about it kind of as a game of Go Fish. Alright, this index is telling you how many of a kind you need to be able to pull that number out of the house. Alright, so this is saying I need 5 2's for me to be able to remove a 2 from the radical. And I just so happen to have 5 of them right there. Alright, so the fifth root of 32 is just 2. But don't forget we have that cube on the outside. And so 2 cubed is 8. Now, it might seem a little redundant the way that I'm doing it here, but not all expressions can be perfectly simplified into a single number. Alright, so you're going to see that over there with the 50. So just kind of bear with me. Here's my ugly little dividing lines. Let's try the middle one. Now if you notice, this middle one has a negative exponent. Alright, and you might not remember what a negative exponent does. Alright, it acts kind of like a light switch. Alright, I'm going to try to draw a light switch here. It's not going to be a great light switch, but it's... So here's my light switch, right? And imagine that light switch is kind of like a fraction. Okay? So what this negative exponent does is it kind of flips the switch about where in the fraction this expression should go. So if you have a negative exponent, you need to flip the switch and move this expression to the other side of the fraction. So instead of dealing with 27 to the 2/3, I'm going to deal with 1 over 27 to the 2/3. Alright, that's what that negative does. Okay, we're using a property that looks like this. It's a to the negative 1 equals 1 over a to the 1. That's what the property usually looks like. So here we go. So I'm going to evaluate the 27 to the 2/3 kind of separately, and then I'll pop it under that 1 probably. Alright, so 27 to the 2/3. Now, I'm going to have the cube root of 27. I'm just deciding where I want to put the 2. Alright, I'm going to put it out here like I normally do, just because I want to see if I can cube root that 27 easily. Now most of the time you can go into a calculator and it will, like, you could see if you get a clean root. That's what I would do because I'm lazy, but I'm going to show you how to do it by hand. Now 27 is 3 times 9, and 9 is 3 times 3. So when I'm talking about the cube root of 27, I'm looking at the cube root of 3 times 3 times 3, and then I'm squaring it. So that means that I need 3 of a kind to remove the 3 from the house, and I have that. So this is 1 over 3 squared, which is the same thing as 1/9. Alrighty. So now this last one, I promised y'all, I said, hey, this will not work out cleanly. So let's check it out. So the reason why I know it won't work out cleanly is I know that 50 is 25 times 2, and 25 is 5 times 5. So because this isn't it isn't the same number being multiplied times itself over and over, I know that the fourth root of 50 will not evaluate cleanly. So in this case, what I'm going to do is I'm going to have the cubed on the inside here with the 50. And so what does that do? Alright, now 50, I know that 50 is the same thing as 5 squared times 2. Right? There it is. There's the 5 squared and there's the 2. Now if I'm cubing it, I'm going to go ahead and use my power of a power property, which says I can distribute that cube across the multiplication here. So this is going to turn into 5 to the 6th times 2 cubed. So what I'm really saying here is I have 6 5s all listed under here, and I have 3 2s listed under here, but I'm lazy and don't want to write them all. Okay, so what I'm looking for, because I'm lazy and don't want to write it all, is I'm looking for numbers where the exponent on the inside is bigger than the exponent on the outside. And I'm going to pull out part of those. So this index says that I need 4 of a kind in order to remove a number from the house. So out of the six of these 5s here, I'm going to take 4 of them and use it to put a 5 outside the house. Well, what does that mean? That means that there's still 2 of them in there, right? Now let's look at the 2 cubed. So with the 2 cubed, I don't have 4 of a kind, so it's going to stay as 2 cubed. Right? Now to get the simplest form here, we can't have this cubic stuff in here. We got to, could I say it, maybe recongeal? That's a gross word, but there it is. So we got to multiply these all back together. So 5 squared is 25, and 2 cubed is 8. So I'm looking at 5 times the fourth root of 200. Alright, now this is the simplified form. Alrighty, so let's look at another one. I think example 3 keeps going. Yeah. So example 3 is talking about the, I don't know how to pronounce that, Fujita scale rating? I don't know what it is. F of a tornado. Alright, so here it is. This ugly formula, where W is the estimated wind speed of the tornado in miles per hour. So they want us to find out the scale rating, the F, of a tornado when the W is 100. So they're just saying to plug that in. I'm going to do it in red since I have those green lines down there. Now this honestly is going to be a lot of calculator work. And the reason why I know it's calculator work is because I have a decimal down here. You can't really easily take a cube root and square stuff and divide. You're just going to get ugly decimals. Alright, and that's going to kind of suck. But I'm going to show you how to evaluate by hand a little bit before it comes to calculator work. Because this also looks terrible to plug into a calculator, doesn't it? Let's see. So here's what I do in my calculator. Alright, I'm going to start, let me open up my, I iPhone calculator, because that's what a lot of you guys use, right? I'm going to start by doing 100 divided by the 14.1. Alright, that's like roughly 7.09-ish. Now I'm keeping that in my calculator. Ooh, here's another thing. Be aware of where that radical ends. You see how I got a little too excited up here and I covered my 2? I'm not taking the square root of that minus 2. Some people like to go ahead and put, call it a rain gutter on their house. They like to put the little line there to remind you where the radical ends. Just be aware it's not a 1 sitting in there. Alright, so I got roughly 7.09-ish. So, I turn my calculator on the side. I'm going to square it, which is about 50. And then I need to take the cube root of it. Alright, so my calculator right now is giving me roughly 3.69 minus 2, so that scale is 1.69. Alright, so that's how you do it. And a lot of these things are kind of calculator things. So let's check out some of these other ones. I'm going to try to make these a little bigger for posterity's sake. There we go. That's a little exciting. Now recognize that some of these things can't be evaluated very easily, right? This one will be. I can do this bad boy by hand. But the decimal? Psh, throw that in a calculator. Come on now. Recognize here that the negative is outside the grouping symbol. So no matter what we do when we evaluate all this stuff in here, it's coming out as a negative, okay? So that 4 down there, that turns into a 4th root of 16. And I know the 4th root of 16, we already did that. And I'm going to cube it. Okay? So the 4th root of 16 is either 2 or negative 2. Alright, so I have negative plus or minus 2 cubed. Ooh, I should have kept it small. That's alright. This guy's going to come over here. Now recognize there's 2 numbers there. Alright, so you should probably break this up into two expressions. In the first one, I have negative 2 being cubed. In the second one, I have negative 2 being cubed. Okay? Apologize if you can hear my cat. She's excited this morning. Alright, so checking this out. 2 cubed is 8, and there's a negative there, so this is negative 8. Here, negative 2 cubed is actually a negative 8. So I'm looking at negative 8, which is a positive 8. So there's my 2 solutions. Now this b here, y'all, this is just calculator work here. Okay, this is not something where I would say to really do much with. So here's what I would do, is I would actually evaluate the 3.5 and raise it to the 4th. You should get about 150.0625. And then take the 5th root of it. Oh, which isn't very friendly on a calculator, I tell you what. Let's see. So what I'm doing is I'm looking at the iPhone, seeing how y'all nerdy kids should do it. Scratch that. Here's how I would do it on the iPhone. So on the iPhone, here's what we should do. So I'm going to actually turn this back into an exponential form. So it's 3.5 to the 4/5. So in my calculator, what I'm doing So I'm going to put 3.5, and there's a button. Looks like this. It says x to the y. So what it's saying is you're raising it to some kind of exponent. Now it's really important when you go to type in this exponent, the 4/5, that you use parentheses. Okay, so that didn't work well at all. I'll have to play with the iPhone to figure it out. Honestly, I recommend just using Desmos, because Desmos is a lot friendlier. Let's see, I believe my tab will share with you. This will make it easier for you to see as well. So phone calculators don't really have like a nice way to type it in, but watch out. Watch out with Desmos here. Alright, so I have my 3.5. I've used Shift 6 to bring it up into the exponent. I use my parentheses and put 4/5 in there. Oops. And it closes the parentheses automatically for you. Kind of. You should get about 2.7. Alright, now it makes sense that our number is smaller because that fifth is a fifth root as opposed to raising to the fourth power, okay? So if you have a fraction that has a denominator bigger than the numerator, then you're going to be looking at a smaller number as your output, okay? But there we have it. That is kind of a long way around that one. I apologize. But that's evaluating expressions with rational exponents. Until next time.